Hello, today I'll be demonstrating several methods for dividing a polynomial. Before I tackle the actual problem, I'll quickly go over the concept of dividing polynomials. Here is the division statement. It is a statement where, if the dividend and the divisor are polynomials, and d of x is not 0, there are two unique polynomials q of x and r of x that make the statement true. A thing to note is that the degree of the remainder is less than the degree of the divisor. Additionally, if the remainder is 0, that means that the dividend is divisible by the divisor and that the divisor is a factor of the dividend. So now on to the actual problem. The first method is the long division algorithm. This method is very similar to that of regular long division, but this time the focus will be on the leading terms of both the divisor and the polynomials involved, rather than on the polynomials as a whole. Each iteration of the algorithm, a term must be found so that when the leading term of the divisor is multiplied by this term, it can be used to cancel out the leading term of the current polynomial in the algorithm. Once this term is found, all terms of the divisor must be multiplied by this term and then subtracted from the current polynomial. As this is an algorithm, all that is left to do is to repeat this process until the result of subtracting has a degree less than the divisor, which in this case is 1. Now that a constant number has been reached, that is the remainder. The next method is the synthetic division algorithm. It is a shorthand method for dividing a polynomial by a linear divisor x minus b. First, the coefficients of all the terms in the dividend are brought down, including the ones that are 0. This method involves the multiplication of b, which in this case is -2, by numbers found in the algorithm. To begin, the leading coefficient is brought down, and then it is multiplied by b. The result of this is written underneath the next coefficient, and the two numbers are added together. Now this result is multiplied by b, and the algorithm continues until the last addition. The numbers found, except for the last one, then form the quotient, where the first slot represents the coefficient of x, which is to the power of 1 less than the dividend. The last number is the remainder. The final method is the remainder theorem. This theorem states that if a polynomial p of x is divided by x minus b, then the remainder is p of b. Therefore, the remainder in this case will be p of -2. To find the answer, -2 is plugged into the equation and the polynomial is simplified. The result is -51, which is confirmed by the two previous methods. These methods come in handy when factoring polynomials, and each one has its use in different situations and has limits in others. Thanks for watching.